Hey guys, welcome back. We'll continue with the book Cracking Codes with Python, and today we're going to cover Simple Substitution Cipher. The encryption programs we covered so far could relatively easily be broken because they only had thousands of keys available. But the substitution cipher can have trillions and trillions of keys and is therefore effectively immune to brute force attacks. So let's get right into it. We saw in the last episode that the affine cipher has only about 1,000 possible keys, and therefore a computer can still brute force through all the possible keys and the message is not secure. The simple substitution cipher is a cipher that is very secure and can effectively not be broken using a brute force attack. And the reason is that there is such a huge number of possible keys that even if a computer could try 1 trillion keys every second, it would still take 12 million years to try out every possible key. And the simple substitution cipher works by reassigning each character that we want to encrypt with a different random character. So for instance, if we take the alphabet from A all the way up to Z, we can take a random letter and assign it to the letter A, for example V. Then we can take a different letter, J, and assign it to B, and so on and so forth. We just need to make sure that we don't use any of the characters twice in our key. And other than the Caesar cipher, we are not simply shifting the position on a cipher wheel, but we are basically putting all the possible characters here in a random order and then reassign them. And that gives us a huge number of possible keys. If we just take a look at the 26 characters of the alphabet, we have 26 factorial different possible keys. So this is effectively this number of keys available to us. And with such a huge number of possible keys, it's basically impossible to brute force a message encrypted using this simple substitution cipher. So in contrast to, for instance, the Caesar cipher, where we simply used a number, for example 5, to shift every letter of the character by 5 positions over, in the case of the simple substitution cipher, we used a much more complex key. For instance, in our example down here, this would be our key. So those are all the letters of the alphabet rearranged in a random order. And by having such a longer key and so many different options of rearranging the different letters, the simple substitution cipher is a lot more secure. So let's open up idle and let's create a new file to implement our simple substitution cipher. We can save the file as simplesubcipher.py. And the first thing we're going to do is to import 3 different modules. Our paperclip module to copy and paste our encrypted message, and the sys module to exit our program, and the random module to generate a random number. Next up, we define the different symbols that can be used, the different letters as a constant. So these are all the letters of the alphabet. And after that, we can define our main function. Here we have the message that we want to encrypt. And below that, we have our key. So we can see again, we have 26 characters in our key. This is basically the same number as the number of letters that we are using, but they are of course rearranged. And then we can select the mode, either encrypt or decrypt. And we are first checking if our key is valid or not. A key is invalid if the number of characters inside of our key does not match the number of letters available. And that is of course a requirement, because if we take a look again at how the simple substitution cipher works, we always need to match a letter from our plain text to the letter of our ciphertext. So if the number of letters in our plain text does not match the number of letters in our ciphertext, then we won't be able to encrypt or decrypt all the different letters properly. But if that's the case, if the key is invalid, then we're going to exit the program with the message that there's an error in the key or symbol set. And after that, we are checking which kind of mode we are using. So if we are encrypting or decrypting our message. If we are encrypting our message, we are going to call the encrypt message function with our key and our message, and we're storing the result back and translate it. And if instead we try to decrypt a message, then we're going to call the decrypt message function. After that, we're going to print out which key we have been using. We're printing out whether or not we encrypted or decrypted the message. And then we're printing out the result of our translated variable. So that's either going to be the encrypted message or the decrypted message. And we're also going to copy it using the paperclip module, so that we can paste our encrypted or decrypted message somewhere else. And we also notify the user that this message has been copied to the clipboard. So let's have a closer look at the actual functions that we are using inside of our main function. So the first one is the key is valid function. And if you take a look at that, we can see the key is valid function accepts a key as an argument. And then we're using the list function to turn our key, which of course is a string of characters, into a list. And we are going to store that in the key list variable. We are also going to take our letters that we are using and turn that into a list as well, which we are going to store in letters list. So we basically have two separate lists, the key list and the letter list. And then we use the sort function, which sorts the different characters for us. We're going to sort both lists. And the reason we need to turn our string into a list is that we can sort characters in a list, but not in a string. So therefore we're going to sort both the key list and the letters list. And since both the key and our letters constant contain the same characters, just in a different order, in the case of the key, when we sort it, we should actually get the exact same list back. So after that, we are checking whether the key list and the letter list are identical, and we are going to return the value. So this is going to return either true or false. If the key uses the same letters as the letters constant, just in a different order, then this is going to be true, and therefore key is valid is going to return true. But if the key, for example, uses letters multiple times, or for example has fewer letters, or in some other way differs from the letters constant, then this is going to return false, and therefore key is valid will return false. And of course, if key is valid is false, then not false will evaluate to true, and therefore we're going to call the exit function here, which is part of the sys module, and we are going to abort our program with the message there's an error in the key or symbol set. After that, we are checking whether my mode is set to encrypt or to decrypt, and if it's set to encrypt, we are going to call the encrypt message function, passing the key and the message as arguments. And if you take a look at the encrypt message and the decrypt message function, we can see that they simply have a single line. We're going to return translate message with the key, message, and the string encrypt for the encrypt message function, or decrypt for the decrypt message function. And we're doing that to avoid code duplication. Effectively, both the encrypt message and the decrypt message function are wrapper functions. So we are wrapping the code of another function, in this case translate message, and return that. And we do that to avoid having to duplicate the code in both those functions. Instead, we're calling translate message with the key, message, and the mode passed to it. And here we first of all have an empty string translated, which is going to store our translated, so encrypted or decrypted message. Then we have two characters. Chars A holds the values for the letters constant, and chars B is going to hold the key. And now we are checking if the mode is set to decrypt. And if that's the case, then we are simply going to swap the value for chars A and chars B by using this multiple assignment statement. And by doing that, we basically can use the same function for both encrypt and decrypt message, and we basically save on writing an additional function. And the reason that works is that when we encrypt or decrypt a message, all we do is basically check the upper row and match it to the lower row if we are encrypting a message, or if we are decrypting a message, we go the other way around. So we're checking the letter in the lower row and then match it to the character in the upper row. And the switching around from checking the upper row versus the lower row or the other way around is simply accomplished by switching the values for chars A and chars B. We're then going through each symbol in our message using a for loop, and we are first checking if the symbol is inside of our chars A variable, so basically in our list of letters that we have. And to account for both cases that we are covering lowercase and uppercase characters, we are simply going to use the upper function here on the symbol, so we are turning that symbol into uppercase, and therefore we can make sure that here our letters constant only needs to contain uppercase letters. So if the symbol is a symbol that's included in our letters constant, then we are going to find its position inside of that letter by using the find function, and we're going to store that in symindex. And then we are checking if the symbol is uppercase. So isUpper is going to return true if a symbol is uppercase, and false if it's lowercase. So if it's uppercase, then we are going to find the character with that index for chars B, so with the key, and then we are calling upper to it to maintain the correct case and adding it to our translated string. And if it's lowercase instead, we are doing the same. We are finding out the index, but we are calling lower on it. So we maintain the correct case, and then we're adding it to the translated string as well. So let's say, for example, we have the character E. So we are going to find its index in our letters list. So if we take a look at that, the letter E here is in 5th position. If we start our index with 0, then we know that E would have an index of 4. 0, 1, 2, 3, 4. And we're going to take that index 4, and then we look for the correct symbol in our key. So again, we are looking at the symbol with index 4. So we're going to start with 0, 1, 2, 3, 4. So in this case, we would get the letter G, and that would be the character that we use in place of E. And of course, depending on whether the E is uppercase as here or lowercase, we would then use an uppercase G or lowercase g. Now, if the symbol we are looking at is not inside of our letters list here, then we are simply going to add it without doing any modifications. And that way we can account for numbers, for instance, which in this example would not be encrypted, and also any additional characters. And of course, after running through all the different symbols and creating the translated string, we are going to return that translated string. And just to make it easier to generate a random key, we add an additional function getRandomKey, which is going to take the letters constant, turns it into a list, and then uses the shuffle function, which is part of the random module, to switch the elements of the list to random order. So we're basically shuffling all the letters into a random order. And then we are going to use the join function to join the elements of our lists together and create a new string with letters that are in a random order. And we're going to return that. And of course, at the very end, we are using our if statement again to make sure that our main function is executed automatically when we run the program. Now with this set up, let's run our program by selecting Run Module. And here we can see we are using this specific key to encrypt our message. And this is our encrypted message. So we cannot make out what the original message was, and it's basically impossible to break this message using brute force. Let's take a look at the practice questions. The first question is, why can't a brute force attack be used against a simple substitution cipher even with a powerful supercomputer? And the reason is that we have such a huge number of keys that it would take a very long time to try out all the different keys. So if we have a large number of letters that we are using for our key, then even if our computer could try out 1 trillion keys every second, it would still take 12 million years to try every key. So therefore a brute force approach is basically impossible even if we use a supercomputer. The next question is, what does a spam variable contain after running this code? So here we have a list spam with the values 4, 6, 2 and 8. And then we are using the sort function on spam to sort the elements in our list. And by default, the sort function orders the elements of a list in ascending order. After running this, we would have those elements in our list sorted. So the values would be 2, 4, 6 and 8. So let's open up idle and let's try this out. We have our spam list here and we are calling sort on it. And now if we take a look at spam, we can indeed see that the order of elements has changed. And we are starting from the smallest element 2, then 4, 6 and 8. The next question is, what is a wrapper function? So a wrapper function calls another function, passing its argument to the function and returning what the function returns. So we used the wrapper function when we worked with the encrypt message and decrypt message function, which both simply called the translate message function, and therefore we avoided having to duplicate the code in both the encrypt message and decrypt message function. What does the following code evaluate to? The string hello, and we call is lower on it. So here we are going to either get back true or false when we call is lower, and since all the characters in our string hello are lowercase, is lower will evaluate to true. Let's have a look at that in our interactive shell in idle, and indeed we get true back as a return value from calling this function. Next question, what does the string hello 1, 2, 3 and we call is upper on it evaluate to? So hello is in all uppercase characters, and 1, 2, 3 of course simply are numbers, it cannot be uppercased. So therefore, since the string hello is in all uppercase characters, is upper will evaluate true. So let's have a look at that in the interactive shell, and indeed we can see is upper evaluates to true. And what does the string 1, 2, 3 is lower evaluate to? So we know that isLower returns true if the string is in lowercase characters and false if it isn't. Now in the case of 1, 2, 3, those numbers of course can neither be lowercase nor uppercase. So therefore both isLower and also isUpper would evaluate to false, and this expression should be false. Let's have a look at that in the interactive shell. We have the string 1, 2, 3. We call isLower on it, and indeed it evaluates to false. In fact, all letter must be lowercase, and the string would have to have at least one letter for isLower to return true. So if we do this, we have the letter L, and then 1, 2, 3, and we call isLower on it. That would evaluate to true because we have at least one letter in it, and that is lowercase. We covered how we can work with the substitution cipher, which basically cannot be hacked using a brute force approach. However, we are still able to hack the substitution cipher using a more intelligent algorithm. We're going to cover that in the next video. Feel free to subscribe to the channel to stay up to date, and see you guys in the next video.